Hello friends, we are going to start the machine learning playlist. In this machine learning playlist, we all completed the algorithms. Every algorithm here we take. So start it. First, we have to understand what is the machine learning. Machine learning, it means we give a machine to the brain that can decide all by himself. This type of machine we call as a machine learning. In machine learning we have two type. First type is a supervised machine learning, second is a unsupervised, and third one is a semi-supervised. But mostly semi-supervised is not used. Mostly we use supervised and unsupervised. In supervised we have a regression. In supervised we have a regression and classification. In unsupervised we have a clustering. So first we have to understand what is supervised and what is unsupervised. In supervised we have a label data. It means we have in dataset we have a target column. For example, in housing dataset we have a price column. This price column is a dependent column. It is depend on all other feature. This type of dataset or problem set we call as a supervised machine learning. In unsupervised we just create a group, create a cluster of the data. This is we call unsupervised machine learning. In supervised we have lots of algorithm. First algorithm is a linear regression, second is a logistic regression, third one is a KNN, it means K nearest neighbor, fourth one is a naive Bayes, fifth one is a decision tree, sixth one is a random forest, and seventh one is a AdaBoost, eighth one is a gradient boosting, ninth one is a XGBoost, 10th is K-mean. And actually K-mean it belongs to the unsupervised, and last algorithm of supervised machine learning is SVM. And in unsupervised we have a K-mean, hierarchical mean clustering, DB scan, and lots of other algorithm. So here we start the first our algorithm. It is a linear regression. So in linear regression here in this PDF you see that the first our algorithm is a linear regression. In linear regression our main task is find out the best fit line. So here it is a final aim is find out this best fit line. How we gonna find out? It is in upcoming process you completely understand how it is find out. So just consider this graph. This in x-axis we have a dependent variable. In y-axis we have an independent variable. In y-axis we have a dependent variable. So do you know equation of line? Equation of line is y equal to mx plus c. This equation we also write as a y equal to beta 0 x into beta 1 into x plus 0, and it hypothesis testing. In hypothesis testing form we also write as a h0 of x into theta 0 into theta 1 into x. So here we find out the best fit line. We consider as a hypothesis equation. So here we consider h1 h0 x h of x equal to theta 0 plus theta 1 into x. Here we have to understand the theta 0 it is a intercept and theta 1 it is a coefficient of x. So coefficient of x, theta 0 is a intercept and theta 1 is a coefficient of x. It means it is a slope. So here, so this is the cost function for our this algorithm. what is the cost function? j of theta 0 comma theta 1 equal to 1 divided by 2m into summation of I equal to m into m in bracket h theta into xi minus yi square. This is the cost function of the linear regression. So in this process, for simple calculation we just consider a theta 0 equal to 1. It means our line, base fit line passing through the origin. Okay, this is right. Did you understand? Theta 0 means our base fit line passing through the origin. Okay, now if theta 0 is 0, then our remaining line of equation, it is a h of x equal to theta 1 into x. If theta 1, let's consider it, if theta 1 equal to 1, then h of 1 equal to 1. H of 2, it means h of 2 means h of 2 means 1 into 2, and h of 3 means 1 into 3 equal to 3. So here we find out the line. Just draw the line. What is the line? Actual actual point are draw in a cross mark. 1 into 1, 2 into 2, and 3 into 3, and our line goes through that actual point. So this is line for a theta 1 equal to 1. Now second equation. So for this line we just calculate the cost function. How we calculate the cost function? Using this formula. This formula, just we put the value 1 divided by 2m. It means what is the, in this formula, what is the theta 0 of x, and here we calculate the value of theta 0. So we just replace them in this formula. So 1 divided minus 1 square plus 2 divided minus 2 square plus 3 divided minus 3 square. This is equal to 0. So our cost function of the theta 1 equal to, cost function of theta 1 equal to 0 is also, cost function is 0. So for similarly this calculation, we just calculate for theta 1 equal to 0.5. Same process. Using our same process, we just calculate the cost function. Cost function is a 0.58. And same process we also follow for the theta 1 equal to 0. And theta 1 equal to 0, here we have a 2.63. This same process we follow for the theta 1 equal to 0. So here we draw the graph. In x-axis we have a theta 1 value. In y-axis we have a j of theta. It means it is a cost function. So we just draw the graph. What is the graph? For 0.05, what is our cost function? Cost function is our 2.63. So here it is a point 2.63. Did you see it? Here it is our point 2.63. So just like that we take a theta 1 equal to 1. So in theta 1 equal to 1, our cost function is a, let's see here, is theta 1 equal to 0, our cost function is also 0. So now here our theta 1 equal to 0 and cost function also 0, we draw this point. Now for a theta 1 equal to 2, if theta 1 equal to 2, we calculate our cost function. Cost function it is again a 2.63. So we just connect this dot and draw the line. This is a create a parabola. We call it as a parabola. In this parabola we have a one and only one global minima. This is we called as a gradient descent. Yeah, do you completely understand what is the gradient descent? Now we going to the next part, gradient descent conversion algorithm. So what is the gradient descent conversion algorithm? Gradient descent conversion algorithm, it is a okay, just fine. If we calculate this process for only 3 points, in real time world we don't have a only 3 points. In real data set we have a million or billion data points. So how we gonna process this, how we gonna follow this process? This is very difficult. So that's why here we use the gradient descent conversion algorithm. Using of this conversion algorithm, process will go very smooth. Computer what we say, it is a behind the algorithm does not need a more power or more accuracy to the operate this algorithm. That's why here we use the gradient descent conversion algorithm. So what is the gradient descent conversion algorithm? What is the formula of the gradient descent conversion algorithm? Is j theta of j equal to theta of j minus alpha. Alpha means here it is alpha. Alpha is a learning rate. It means we decided here we have to decide what is the value of alpha, and this is the derivative of j theta of x. It is actually a slope. Okay, in this formula we just rewrite it in our new way to just understand how it is a work. So instead of j theta we just write theta of new equal to theta of old minus alpha into derivative of old. So this is the slope. In slope, so okay, this is the just a slope. Okay, consider a point A is negative. So here we consider in this graph we just here we have to understand that the when line, how we should gonna decide the slope is positive or negative. So there is only one simple trick, is that the right hand side of the line is going to down or up. In this point, let's consider the point A. If point A we consider, the right hand side of this line, it's going to the down. It means it is a negative slope. Okay, so in this we just take a point A, consider the point A, and point A is, now we see that point A is a negative slope. So that's why here we in this formula we just replace the value. So theta of new approximately theta of old minus alpha into some negative value. Okay, this is some negative value. So next step, theta old plus minus positive. So here we have a plus and it is a positive value. It means in old value we had some value in old theta. So here we have to understand that theta new, it is a greater than theta old. So in this graph, if we consider it here it is our first what we say, it is a old theta 1. In old theta 1 it is a greater than, or if old theta 1 is here and new theta it is a greater than, it means it's go slowly to the global minima. Okay, it is a grow slowly to the global minima. Okay, this scenario we follow from this point, A point. Now we are going to understand the from point B. What is the scenario of happening in point B? So we have to understand that point B, what is scenario we are going to happen. If we consider the point B, theta new is approximately theta old minus alpha into positive 1. How it is a positive 1? Because right hand side of the line it's going to the upward. Now just I told you earlier, if how we gonna find out the slope is going to positive or negative? It just depend on the right hand side of the line. It's going to downward, it means it have a negative slope. If right hand side of the it is a right hand side of the line is going to the upward, it means it is a positive slope. So according to this logic, here we have to just take a positive value. We don't know what is the value of derivative or not, but we just know that it is a positive value. So here we take a positive value into negative value, it is a negative value. So in old value just we negative some value, it means that our new theta 1 it is a lesser than old theta 1. So our present point is belong to the here and new point is belong to the here, and it is a using of learning rate, we just go slowly to the global minima. This is the just a gradient descent conversion algorithm. That's it. There is no any fancy words or anything. This is it. If you have a strong understanding of linear regression, then upcoming algorithm it does not have a, you don't have to put any effort. If you understand completely this algorithm, there is no need to panic or there is no need to make extra effort to the understanding the upcoming algorithm. So that's why linear algorithm it is a one of the most algorithm I suggest you to the study in deeply. So that's why here we are going to find out the what is the advantages of and disadvantages. Before we find out the what is advantages and disadvantages, you have to understand what is the alpha. Alpha is a hyperparameter. Hyperparameter, it means we have to manually decide that what value we are giving to the alpha. So alpha is learning rate, we call it as a learning rate. If alpha is small value, then conversion V is going slowly. It means that for if alpha have a small value, then let's consider that here we have 2. If alpha have a 0.02, it means it's go to the 1.8 into 1.6. After one conversion, it's go to 1.6. It means it's go very slow to the global minima. If alpha is very large value, then conversion is very fast. So if conversion is going to very fast, it take huge step. It means it take huge step and it not going to the global minima. Let's consider it in this graph. For example, here we start going to the point B. Okay, now you say point B. Yeah. So if you start from point B, then if you take a huge number for a learning rate, then it is going to this direction. After that one conversion is happening, then it go to this direction. After that it go to this direction, and this scenario repeatedly happened. It does not reach to the global minima. So that's the reason why we don't take a learning rate as a high value. We always suggest that the alpha it's always a low value, and this is a binary linear regression. And in your mind you thinking like that. So if in our data set we don't have only 2 columns, so this type of data set, if multiple linear regression, we use this formula s theta of x into theta 1 into x plus theta 2 into x2 theta 3 into x2 dot 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 xn into xn. Here we also consider it as there is one thing I should add in here, theta 0, because theta 0 it is a intercept, and theta 1, theta 2, theta 3, theta 4 and theta n it is a coefficient. This is it clear? Now we are going to the next part. It is a advantage and disadvantages of linear regression. There is only what is advantages and disadvantages? There is only one global minima. That's the main advantage of the gradient descent. Because we have only one global minima, then whenever you start, your final aim is going to the global minima. If we have lots of local minima, there is a slightest possibility that you are going to stuck in local minima. So that does not happen in a gradient descent. It is a different, it is a differentiable because it have a quadratic equation. And what is the disadvantage of gradient descent? Not robust to the outlier, because it is a penalize the error. The way benefit line is very impact, because it is a not robust to the outlier. And like I said earlier, RMSE, it means root mean square error. This is the formula of root mean square error. This is the formula of root mean square error. Just this formula. And using, now here we say that here we take a square. It means that we find out the error, and after finding the error we just give it as a square. So value going to increase. In this point, just say that, just explain this. MAE means square error, penalize the error. Okay. And second function we are going to use it as a mean absolute error. We call it as a MAE. In MAE, cost function is going to little bit different. 1 divided by 2m, I equal to 1 to m, y hat minus y1. Y hat is equal to theta 1 into theta x, because in previous formula we use theta 0. If we have to outlier in our data set, we does not take the pre-measurement of about the outlier. So in this scenario we are going to use MAE, means mean absolute error. It is using subgradient. So this is it for today. In next video we are going to understand that performance matrix of linear regression. What is performance matrix? What is R square, adjusted R square? What is the difference between adjusted R square? And what are the assumption regarding the linear regression? Okay, just we complete the assumption about the linear regression. After that, in next video we are going to explain the what is R square and adjusted R square. After that, we are going to explain what is the overfitting, underfitting and generalized model. So here there is only it is take 2 or 3 minutes to complete this point. We just take it and move to the next part of, just stop this video, and in tomorrow we are going to explain lots of things. So what are the assumptions we have to take before using machine learning? I don't say machine learning, but linear regression model. First assumption is that there is a linear relationship between x and y. So first assumption is that there is a linear relationship between x and y. X means it is a independent variable. Independent variable means it is a predictor, and it is a predictor. Y means it is a dependent variable. Independent feature should have a normally distributed. Before using linear regression, we have to just use of feature scaling. This point is said just that always take care of multi-coordinarity, because in linear regression is not very well performed on a multi-coordinarity. That's why here we have to take care of multi-coordinarity. Homoscedasticity, it means that all x have a same variance. It means that every features, every column have a same variance. If we calculate the first column variance, second column variance and third column variance, they have a same variance. This is called as a homoscedasticity. Fifth one is a feature scaling. Feature scaling means it's the standardization or normalization. It is required for this matter. And sixth one is a homoscedasticity. This is it. This is the sixth assumption we have to take care before using linear regression in linear regression. After that, in next video we are going to understand what is the overfitting, underfitting, generic model, and in performance matrix also we have to cover it. First one is a R square and second one is a adjusted R square. What is the difference between R square and adjusted R square? And after that we are going to start in ridge and lasso and elastinate. These are the three topics we are going to cover in a next video. This is it for today. Thank you.